Welcome back to another video. In this video, I will talk about decorators in Python. So I think at this point, you're probably aware of the function concept, and it's a really powerful concept. I would say if there's one really powerful concept in programming, I would say it's the concept of functions, to be honest, because it's really powerful and you can do many things with them. And so to understand what a decorator is, I think it's important to understand things like scope and functions. But the definition of a decorator is that a decorator is a function that takes another function and extends its behavior without modifying it. So I usually like to think of it as it's kind of like a function that takes in another function as an input, but it can also do more than what the function is doing. So it kind of runs it, but it kind of does many things as well that would make the whole execution, it would kind of serve as a utility or kind of do more than just the basic function, okay, if that makes sense. So to understand this, you need to understand that a function is like a machine. So even though functions do not always return something, but they usually, when they do, then you could think of it as a factory. So it takes something in and spits something out. And by taking in a function, this also allows the function to actually execute that input, if that makes sense, or it executes the function. Quite abstract maybe at this point, but let's try to do something really simple. So I'll just say def. I will define a function and I'll say my decorator, okay, and I will say func as a parameter, okay, and inside of it I will define a new function. And this is also interesting to know that you can actually define functions within functions. If you I think I've forgotten to mention that before. So I'll say this is a wrapper, and I'll say starting the wrapper, and then I will call the function inside of this wrapper, and then I will print ending the wrapper. And finally, before so the whole thing is that this function takes in a function as parameter and returns a new function. So it has to return the wrapper. Note that I'm not returning this, right? Because I don't want to return the return value of wrapper. I just want to return the function as is. So I only want to return the function. You really have to understand the difference between a function and the function call, so to say. So if I just say wrapper, this is just a function. Or for example, this my decorator, this is just the function itself, whereas my decorator with parentheses, this is the return. It is the return value because it's executing something, and it's what you get here is kind of the return value, and therefore you can save that, say like name, for example, save it to a variable, right? So you really have to understand the difference between the function itself and actually executing something. Let's try to use this decorator now, because right now it's just a function. You see it's quite interesting syntax. So it's like it takes a func and returns a func. Let's define print name, and it can say, maybe take a name as a string, and then we say printing my name. So that's what the function is doing. And now I want to say do something. Okay, I'll say print Bob. Okay, and I'll say my decorator do something. This will not work, right? Because the name is actually print name. And now I will run this. So do some, I will say print Bob, right? If this makes sense. I hope it does. We see that, yeah, so what I notice now, maybe I should not say print Bob, I'll just say print print name. Yeah, I think that's not maybe the best name, because this is not this, right? So if I say f, actually I should say something else. I realize that now. So I should say this is my funk, and I will print my funk. This makes more sense. So to understand this now, I hope it's not confusing. What's happening? We need to understand first and foremost what this is. It's a function that takes a function and returns a function. I hope this makes sense. It's a really powerful concept, decorators. And then I'm defining a function, and then I'm passing that function that I defined as an input to this decorator, right? And I said that this decorator will actually return a new function. So it returns a function which is kind of a super function, if that makes sense, where it's kind of an extended function. It does more than just this now, right? It does something before and something after. So let's try to run this and see what happens. Of course, it failed. Let's see. It says starting the wrapper, and then on line 12, it's saying missing one. Yeah, of course, because this was kind of stupid using this, because I was kind of printing. I'll just say printing something, okay, for the sake of clarity, not doing something really stupid now. So I'll just say printing something, okay, and let's try to run this again. Clear the console, run it. So we see that it runs starting the wrapper, printing something, ending the wrapper. Why? Because, as I said, this function, which is the my decorator, the decorator function, it takes in this function which I defined here. So this means that when it then defines the wrapper, it will run some code, be some really complex logic, but right now it's just a simple print statement, and then it actually runs the function, which is what I passed in. So right now I passed in this, but it could be something else I could pass in as well, right? So this is what also makes it really interesting. And I will give you an example of what you could do with this, because it's quite interesting. And then it runs print again, and then it stops, right? So that's what we see here. Let's try to do something totally different. So what I want to do is I want to have a function that actually, so even though it's not a really interesting example, but I want to create a function that returns the power of something, okay? Or like it multiplies by something. So maybe it's like it takes a function and it should multiply. It takes a number, right? And you can say that maybe you want to have multiple functions, right? So you have one function that can multiply a value by 10. You want to have another function that can multiply a value by 20, you know, but you don't want to define all these functions, right? For some reason you don't want to define them separately. You could say def multiply by 10, and then it will take like a val, and it will turn val times 10. And then if you want to have another thing that does like multiply by 20, then you would have to like say by 20. I think you see where this is going. And let's say you have 20 variations of this. You don't want to have 20 function definitions, right? So a simpler way to do this is to actually use a decorator. I think that this is a good example of a decorator. So instead, you could say that, hey, instead of doing this, I'll just say multiply decorator, okay? And it takes a function, and then it defines the actual function inside, right? So I'll say multiply by value, and it will take a val, and it will actually it will say it will So I would say that it will take return func, right? And it will take the val, right? Yeah. So to illustrate this a bit more, it's not the most perfect example, but just to give you some hint of what you can do. So this is a decorator, maybe a stupid one, not sure. But let's look at this code, okay? So it's a decorator, and I said that decorator is a function that takes a function and returns a function. So it takes this function, and then it says, okay, multiply by value, even though this is not correct. I would say it's actually maybe add with value, right? So it takes a value, it takes some result from an input, and then it adds val to it, right? And let's see. Okay, so I just reverted it, but anyways, we see that here we have a multiply function that takes a val and it multiplies 5 with that val. And then finally, I call the decorator, right? So I supply the decorator with this function. So it's 5 times val, and then this will give me a function back, right? So I can call this, I can execute this. So I will execute this with 10. So then the question is, yeah, you maybe already saw the answer, but the question, the answer of it was 60, right? So this is what the result will be. The result will be 60. Let's run this and see what it returns. Yeah, it should return 60. Let's see why it doesn't do that. Yes, because I haven't saved the file, of course. So let's run this again. Yes, now it's 60. So why is it 60? So the reason is that, so as I said, the decorator, it takes the function, which is multiply 5 times val. So it will take this func, which is the multiply function, and then inside of here, it will execute func, which is multiply, with the val, and the val is what? It's 10. So it will take the func, just this one, and it will execute it. So it will take 10, and 5 times 10 is 50, and so this will be 50, and then it will add. So that's why I said that the name here is not convenient. It should be add by value. So it adds what you supply, which was 10. So 50 plus 10 will give 60. I hope this was not really complex. I hope you understand to some extent at least what you can do with this. You can do many things with decorators. This was just a really simple example, maybe not a useful one, but there are many useful cases for using decorators, and this is a style not only used in Python but also in other programming languages. So it's good to know the programming style, at least. Taking functions and returning functions is quite normal, actually. Thanks for watching.